Hello, welcome to this session. My name's George Cann, and I'm the co-founder and CTO of Oxia Palus. Today, I'm going to talk to you about the AI art race, resurrecting lost art with NVIDIA GPUs. So first, I'm just going to talk a little bit about us. So Oxia Palus is an artificial intelligence, RTech or createch startup, resurrecting the world's lost art. We specialize at the nexus of spectroscopy, machine learning, and visual design. Recently, Oxia Palus came third in NVIDIA's top 10 AI developer stories of 2019, and recently featured in NVIDIA's GTC 2020 keynote. In May 2020, we joined NVIDIA's Inception program. On the right, you can see some of our previous work, which has involved uncovering the previous painting behind Picasso's The Old Guitarist, and also reconstructing a landscape that hides behind Picasso's The Crouching Beggar. So in this session, I'm going to talk to you about generative adversarial networks and how they're being utilized with NVIDIA's GPUs combined with multispectral imaging to resurrect the world's lost art. We are going to extend our work from reconstructing a lost Picasso, La Femme Perdue, to reconstruct a lost sketch hidden behind Leonardo da Vinci's Virgin of the Rocks, which is held in the National Gallery as a painting for the first time. This process can be extended to other artwork with available pentimenti, or underpaintings or sketches that have been painted over to reconstruct lost art, which we believe could deepen our understanding of the history of art. So there are two versions of the Virgin of the Rocks. The painting that we're going to focus on is the Virgin of the Rocks in the National Gallery. On the right, you can see a high-resolution crop of the Virgin of the Rocks in the National Gallery. This high-resolution image enables us to do super resolution using the pick-to-pick HD model. So what researchers have found is that when you X-ray the Virgin of the Rocks piece in the National Gallery, there's actually an underlying sketch that Leonardo made of a woman and a child and an angel. The image on the right is an X-ray performed by researchers at Imperial College London. And we're going to use this image to reconstruct a possible version of what this sketch or painting could have been. To do that, we trained a pick-to-pick HD model on a set of Leo Dinesci paintings. In this example, there are 100 paintings, but we've used 225. The images on the right show a set of edge maps with noise added and a holistic nested edge detection applied to all of the paintings that are on the left. We've also then partially augmented and labeled some of these images in order to help the algorithm recognize certain attributes such as skin, hair, and clothing. The black and white image on the left is a trace of the X-ray of the Virgin of the Rocks. We've taken that image on the left and co-registered it with the Imperial X-ray. We've then manually edited that piece, adding in and highlighting certain features such as the face and the hair. We've also labeled that image so that certain features such as skin, hair, and clothing can be more easily identified by the pick-to-pick model. The red box highlights a segment of the piece that we're going to focus on in the next slide. In this video, you'll be able to see how we search for the best possible or the most aesthetically pleasing final result. The video on the left and the right correspond to one another. The left is the input and the right is the result of applying the pick-to-pick Leo Dinesci model on the set images on the left. In our final slide, we present the Madonna. This is the best result, or the most aesthetically pleasing result that we found after exploring all the possible solutions using the color map video in the previous slide. And so the race is on, because we believe this process can be repeated for thousands of pieces of artwork that have pentimenti or underdrawings around the world. Thank you for listening to this talk and taking part in this session. If you'd like to view more of our work, please visit the GTC AI Art Gallery. And if you're ready or interested in learning more about our upcoming projects, please contact us at inquiries@oxiapalus.com. We're also on Twitter. We'd also like to thank NVIDIA for their support through NVIDIA's Inception program. And we'd also like to thank the National Gallery, home of Leonardo da Vinci's Virgin on the Rocks.